Thank you, Pete and Andy, and thank everybody else for not making a mass exodus. Echo's already kind of bad in this room, but I think we're really cramped next door, though. So I want to thank my two co-authors, Katrina Nystrom and Tasha McKee. I think Katrina's here. Could you raise your hand? Hi. Yeah, they get to have all the fun by doing the field work, but my consolation is they send me really good data, and they have been doing so since 2004. So this talk is about an analysis of low flows and really a description of a program that's, to my knowledge, rather unique in this part of the world. It's called the For Barrett Program. That's where landowners sign legal agreements to forego pumping water out of creeks during certain times of the year when flow gets to a low level. I didn't start the program. It was really Tasha McKee, and she's been a driving force. And I also have to confess, this is not the Upper Mattole. This is Redwood Creek down by Redway. It's just the best photo of a dry creek I had. So let's get started here, shrinking flows. Some of the most important controlling factors are climate and what's happening at any given time. In the summer we do have fog, things like fog and wind and clouds and even summer rainfall probably are the main controlling factors in how low flow gets, other factors aside. Vegetation type and age and density is another factor, and I think we're going to hear more about that in some other talks this week. Human-induced changes in the hill slope runoff properties. Some old logging covered almost every square inch of some watersheds, compact soils. That makes storm rainfall run off faster and less of it soaks in to supply groundwater later in the year. And modern-day harvest sometimes promotes younger forests than you find elsewhere. And through some of the work that Andy and others have done, we know that small trees take less water out of the soil per tree, but dense young stands take more per unit area than big trees do. So the younger our forest, the more water they're going to use. And here's an example of, there's even a term for this, doghair fern. It's where, or firs. It's where trees were harvested and even age, dense stands of young trees to come back, and they take a lot of water out of the soil. And everybody's heard about the green rush. Marijuana industry is booming here, and a lot of that requires water taken out of the watersheds from creeks and from the groundwater table. Study done by Bauer and others recently used Google Earth to map grows. In this part of the region, they selected several different watersheds, and this is just one example showing the dot size indicates how big the operation is, and the color indicates whether it's an outdoor or indoor grow. But it's a huge industry and getting bigger by the day. So water users in this simple comic here show people that live along streams often and historically have taken water by directly pumping it out of the creek, surface water. And they may filter it or have a small storage tank, a pressure system to supply water for their domestic use, for growing food and whatnot. But that is a direct and immediate effect on flows. It can make a stream go dry in a matter of minutes if the flow is already low. And even groundwater pumping can have an indirect and somewhat lagged effect on stream flow. It lowers the groundwater table, and you can change a creek that had water flowing into it from the adjacent aquifers to one where water's leaving the creek channel. Cone of depression extends to the creek. So now into this study, Mattole River is in southern Humboldt mostly, and it flows from south to north, down here the watershed area is about 245 square miles. There's a USGS gauging station there near Petrolia. There's another USGS gauging station near Edwardsburg, and I think that drains about 58 square miles. The part of the watershed I'm going to be talking about is upstream from here. This is a critical site in the Sanctuary Forest Monitoring Program. It's called MS6, Main Stem 6. And it's at the downstream end of the reach where they've been focusing their forbearance efforts. And Whitethorn is just upstream from there. So, getting back to the main stem gauges, the Petrolia Gauge has been operated since 1912. There were 2 years back there, 1912 and 13, data were collected. It was abandoned until 1951 and then picked up again. So even with that gap, it's got a pretty good record length for doing some statistical looks at low flows, which is what I've done here. I plotted each summer's 7-day low flow, and that's computed by just looking at the daily flows and picking out the 7-day period of consecutive days that had the lowest flow for that season. And you can do that for every single year and then plot these on an exceedance probability curve. So what we have here is a flow on the y-axis, and on the x-axis is exceedance probability. So when we go to the right-hand side of this curve, those are lower flows with higher exceedance probability. That means they're low enough to be exceeded more often than higher flows further to the left. That's just one way of looking at low flows. You could also talk about recurrence intervals, how low they were. These data for Edwardsburg gauge, the Edwardsburg gauge I think was started in 2001, but what I did to extend the record was to take the Petrolia data and downsize it by drainage area. These larger symbols on each graph are the data plotted from 2001 through 15. So what we can see is that the full data set gives a median value of the exceedance probability of 50%. But because they're all bunched over here, the 2001 through 2015 data show a trend towards much lower flows. The median for those data is 86% exceedance probability. That means it's 80% likely that that flow will be exceeded in any given year, which is a very low flow. And one of the main reasons we care about this is for juvenile fish stranding. These young coho and other salmonids get trapped in isolated pools. When these pools become disconnected by riffle crests going dry, and they're subject to predation, heat stress, and lethal effects. So this is a study area with MS6 down at the downstream end, and some of the other gauging stations that I won't talk about very much in this talk right here, distributed along the channel upstream, and each little green dot is a forbearance location. That's where some landowner has signed a legal document agreeing to stop pumping water out of the creek when notified that flows are low enough for that. And in exchange for that, giving up that right, they've been given large storage tanks to get them through those dry periods. And to date, I've got another slide that shows this. I think there are 25 people along the main stem and another 20 people that aren't in the forbearance program but have voluntarily upsized their storage and comply with the pumping cessation rules. So again, this is not Upper Mattole, this is Redwood Creek, and this is a familiar face to many of you, Bill Eastwood, measuring flow on Redwood Creek. And you can see the channel's pretty big. There should be some significantly higher amount of flow in a creek like this year-round. But he's having them collected in this pipe and then collected at the other end of the pipe in a graduated cylinder. It's down to a dripping. Drops of water he's collecting there. That's how low the flow got last summer. So you have to get creative in trying to measure flow during these drought conditions. So these are all the, I think it's 16 years worth of data collected by sanctuary forest people at the lower index site. We call it MS6. And you can see that I've highlighted the driest year right here, which is 2008, and the wettest year, which was 2005 right here. All the other years are bracketed. This dotted line right here shows the index flow for this site at which people can no longer pump from the creek. That's the flow of about 20 liters per second, which translates to 0.7 cubic feet per second. And so as flow approaches that, sanctuaries forest people keep track of that, and they start putting up signs in the neighborhood. They call people. They send out email notices that it's coming. Get ready to shut your pumps off, fill up your tanks and whatnot. And when it drops below that level, then the pumps are turned off. And in 2005, the wettest year of the ones I'm showing here, nobody ever had to turn the pump off. So that was the wettest summer that we've seen in this monitoring period. And some of the other years in between, you see occasionally flow will bump up a little higher. That's solely because of rainfall. We do get rainfall in the summer here, sometimes an inch, inch and a half. And that can provide some temporary relief, but it usually doesn't last long. So augmenting storage provides a vehicle for forbearance. Who would agree to turning off their pump when they didn't have enough storage to get them through a no pumping period? People have to have water every day. So, oops, there we go. And this is what it looks like in one of the summers, in recent times. This is 2014, 2 summers ago. With the flow along the creek channel, these sites are oriented from upstream at MS1 to downstream at MS6, and the flow threshold is shown there as well. In this case, the forbearance was invoked in a rather conservative manner. The pumping was shut off a little before flows dropped below the threshold and didn't pick up again until the flows had risen somewhat above that. So there's a tendency to err on the side of caution in terms of invoking forbearance. And so this is the progress of the forbearance program through time. I'm not sure where there it is. Yeah, beginning in 2007, oops, I'm sorry. How do I go backwards? There we go. 2007, when tanks started being put in and forbearance agreements were being signed, that first 3-year period there were 7 tanks, and it's been growing steadily to where there are 25 tanks now. There are 25 participants, I should say. And the total storage that's been put in since that time has been almost 6,000 cubic meters, which equates to about 1.5 million gallons, which is starting to make a dent in things in the upper Mattole. The cumulative changing of instantaneous pumping capacity has been about 13.6 liters per second. May not sound like much, but that equates to about half of a cubic feet per second when you add them all together in the watershed. And so we can hypothesize about the benefits to stream flow based on that. These are data from summer of 2015, measured at MS6, which again is the index site. It shows the cutoff of 20 liters per second. It shows the actual flow in the purple line. It got below the cutoff for a certain period. A little rainfall popped it up above, or almost to it again, and but didn't really recover until November. One thing we've been noticing is that the onset of rainfall in the fall is getting later and later these days, it seems. So the dotted line here is a hypothetical. If I took that maximum instantaneous pumping capacity of 13 point something liters per second and subtracted it from the observed data, that's what it would look like. And again, that's kind of a worst case scenario. That assumes that everybody would be turning on their pumps at the same time of day. But it's not that far-fetched. During the summer, things get hot. People need to irrigate at the hottest part of the day. And I'm sure there have been days where everybody's turning on their pump at the same time and you know, taking water from the creek. So that's a pretty substantial benefit. Rather than going to close to zero discharge, this best case scenario shows water staying in the creek channel and flowing and tending to keep pools connected. So the solutions to the drought, in terms of what we could affect, are really increasing and ramping up the tanks and forbearance program. I think the upper Mattole serves as a model to be extended elsewhere around the Redwood region, and you just can't go wrong when you get people to agree to stop pumping from the creek, there's going to be more water in the creek. That's a pretty certain thing there. And we need to be efficient about our usage. I noticed, and you probably noticed if you live around here, there's a lot of very inefficient irrigation happening, spray irrigation, and I don't know how the irrigation, how conservative it is in the other industries up in the hills, but it's something to take a look at. Any leaks, obviously, need to be fixed. And promoting more mature forests over time. This won't happen anytime soon, but the older the forests are, we know from recent work, the less water they're going to use per unit area. So that's what I have. Thank you very much.
Burning questions for Randy? No? Yeah.
Just wondering what kind of size tanks these people need and how long they'll keep them going. And, you know, you had a 50,000 gallon tank, and I think that's about 7,000 cubic feet, which is a pretty big tank. So that was in your cartoon, and that was just for illustration. But what kind of tanks are you talking about, and how long would a given tank keep people going? And
well, these are very durable tanks. I think most of them are made in Australia. They have a conical top like the cartoon I showed. And I think most of them are 50,000. A few are 100,000 or 125,000 gallon tanks.
They're really big tanks.
Yeah, and some of these forbearance participants have more than one tank. They look at their water use and size the tanks to get them through a month or two of no pumping.
Yeah, well, that's what I was wondering. So a given tank would last for a month or two. I mean, obviously it depends on the use and everything else, but...
Yeah, I don't know that part of it.
Yeah, okay. Trying to understand the practicalities of it. It's a great idea. I mean,
We'll cut it off at that point.
Right.
Thank you, Randy.